Hello, my name is Kalty Vazquez, and this is an overview of a program that I made for Dr. Tansel of the FIU Mechatronics Lab. This is an update of a previous video that I have made. We added a few extra features and I wanted to share them with you. So to begin, the project is to create a frequency sweep that starts off on this end of the tube and is picked up by this sensor here. These are piezoelectric sensors, and the objective is to try and detect that tiny notch that's right there in the middle, hoping that a certain frequency reacts differently. Our source that's actually going to be creating our frequencies is a DG1022. Advantage of this system is that we can do a frequency sweep, so we're starting at 1 kilohertz, we're ending at 40 kilohertz, and it takes about 5 seconds to do it. The advantage that this system has is that we can choose a trigger, whether we want to be external or internal. So right now we're using an external trigger, so the program, the actual program can tell it when it wants to do the sweep. So, and then here we have a USB 6210 by National Instruments. This is going to allow us to communicate with the Labview program to actually create a real world input and output. And here we'll be able to measure from these two cables the signals coming back. Thanks to this here, we'll be able to measure what's actually coming out, and we'll also be able to create a trigger. So just a quick overview of the program before we begin. Up here we have the setup tab. Well, here we can choose the duration of the test. So we can have, this is in milliseconds, so right now we have 5,000 milliseconds, which is 5 seconds. And that can be changed to any length of time. The program will adapt to it. The next thing right next to it is a large blue button which turns red. This is the test if you just want a finite test, a certain duration of time, or an infinite test that is used with this threshold test area here, which I'll explain later. You can also change the sampling rate, the samples per second to read, the triggers of the ports. That we're all going to leave constant. And then another addition that we have here is a data logging. Data log can be turned on and off, and you can put the name of the test to where you'd like to save it, and little comments or anything that you would like to actually put into it. The last thing is the values. This is what's actually going to be displayed and saved in the information. So here, this output that we have here is the actual output from our function generator, which is coming out through this port here. Here we have frequency and amplitude, and next on the other side we have what we're actually receiving in frequency and amplitude on this end of the tube. So this is going to be the output, this will be the input. We can read the percent received, we can read the dB gain, and here in the center it has the envelope frequency, which I'll explain later as we do a few tests. So to begin, 5-second shot, and here we go. So, and I'll explain the 4 graphs that you see. This that popped up right now is all the information that's been saved, and I'll go over that right now. So the top square, or the top graph, really just looks like one big white block, but in reality the frequencies are just it's such a high frequency that we have to zoom in more and more to actually be able to see it. And the same thing with the middle one here. The only difference is, on top of it being changing, this shows that as frequency changes, the amplitude that we're receiving back is different. In addition, we're going to zoom in on one little section here. As you can see, there's 2 changes. There isn't just a change in amplitude, which is the thickness. There's also, it's modulated to a certain frequency, which is what the final graph at the bottom here shows us. So the graph at the bottom shows us that it's been modulated, and it's modulating around 77, 78, and it seems to be pretty constant all the way through. So this graph here, the second one, at first it just looks like a yellow blob that just changes in thickness and is modulated at 77 hertz, but in reality, the more and more we zoom in, we can see it's actually just a tiny little wave that the amplitude is changing. So we can just zoom in at any one point, and there we have our wave. Again, we can zoom back out and see the entire duration of the test. And here we go, we're back to what we had before. And the third graph is the gain in dB. So this is obviously negative, so we're starting off at around -60, and we hit a low at about -120 dB, which would be about this point here. And with using the data charts here, you can actually have all the points. We have the actual time in milliseconds, the amplitude, the frequency of the source and of what we're receiving, the gain, the frequency received, and the envelope. And this is all stored in a nice little chart and is then later exported to Excel. Give me 1 second. Is then later exported to Excel with the name of the test, any comments, and this is all the points. For example, this test had 707 points. We can increase the number of points up to about 2,600. Unfortunately, the computer becomes very slow. We can't do tests very long. The more points, the smaller the buffer is. So we have to be able to actually choose, a balance between the two. And the last part of this project, of this program that I'd like to show, is a threshold test. Like I said before, this is normally used with the infinite loop here, and a threshold reads the voltage back. So we're just going to choose a constant frequency. We'll take off the sweep, and we'll choose a constant frequency of, let's say, 1 kilohertz with an amplitude of 5 volts peak to peak. And at about this here, we're getting a 0.1. So we'll say that it gets a point whenever we pass 0.1 volts peak to peak. This light will turn on. Percent received will go with, let's just say, a 7%. And the dB gain will go with anything above a -75. And of course we can just start, and here's our nice constant wave, and here's our amplitude coming back. And again, if anything is touched, let me just zoom out a little bit more because this is gonna jump rather sporadically. As you can see, everything is constant. The gain that we're getting back, everything is constant. And now when I apply some sort of physical pressure, you can see there's a jump in the wave right there. And we can stop the test, and this here again will show us all the information. In addition to that, you can check the timestamp on the bottom of the graph and be able to get any information. And the threshold will light up if there's anything that passes beyond the values that were given. So, and again, all this is saved into an Excel file, and all the information will be saved for, you can save it as long as you need it. And there we go. I hope you enjoyed. Thank you for watching.